Okay, so here we go on quiz number 8. This is kind of a long quiz. Alright, so let's get started. So it says on this first problem, the mean pulse rate in beats per minute of adult males is equal to 69.4 BPM, beats per minute. For a random sample of 134 adults, that's your N, the mean pulse rate is 70.3 beats per minute. Standard deviation is 10.7 beats per minute. Express the original claim in symbolic form. So where did they mention a claim? Claim. The mean pulse rate. So how do you say mean? That's mu. That's like it's a Greek M. I know it looks like a U. We say mu. I'm not going to test you on how to say it, but it's called mu, like almost like a cow, mu, but it's mu. It's a Greek M. Anyway, it looks like a U. It stands for mean. All right, so the mean pulse rate is equal to 69.4. That's the claim, right? The claim, mean pulse rate of adult males is equal to 69.4. Mu is equal to 69.4. Now, identify the null and alternative. Now, how do we identify the null and alternative hypothesis? Well, here's the rule that you really want to learn for this chapter. The null is always equals. The H1 is not equals, greater than, or less than. Always. So that's how it works. So, well, how do we know which is which? Well, it says you start with the claim. Here's the claim. Mu is equal to 69.4. So is that going to go on the HO or the H1? Notice it's equal to. Which one has equals? The HO. So that's the HO. Mu equal to 69.4. Well, then what's left for the alternative? What's H1 going to be? When HO, do we have any reason to do greater than or less than? There's nothing in this problem that says greater than or less than anywhere. So that means we're going to do mu not equal to 69.4. That's what you always do when they never say greater than or less than. If you're wondering, well, how do I know when I do greater than or less than? They'll say it. They'll say it somewhere in the problem. They'll claim, the adults are greater than 69.4 or less than 69.4. They never said that. They just claimed equal to. So I wrote equal to, and then the alternative is the opposite. So what's the opposite? Not equal to. Okay, so there we go. And this one was the claim. It's helpful to put the claim by which one is the claim, because the claim could be HO or H1. This is the null hypothesis, and this is the alternative hypothesis. The claim can be either one of those. We know which one the claim is because they're saying equals to. All right. Okay, here on number 2. Significance level 0.05. We'll get to that in a minute. Original claim. Less than 51% of adults would erase all their personal information online if they could. So let me write that. So you start with the claim. Mu less than, or actually that's going to be a P, I'm sorry. How do you know it's P or mu? It's P if it's a percentage. P stands for proportion or percentage. Really, it stands for proportion. So it's saying less than. So that's why I did less. That way means less than, doesn't it? P is less than. So, as it says right here. Less than 0.51. That's the claim. Okay. Now from the claim, let me write the null and alternative. How do you do it? Well, the null, remember, is always equal. So you write P equals. You have to. That's what the null always is. The null hypothesis, And this is going to be the alternative. It's like two options, like in a court of law, innocent or guilty. So anyway, so the null is always equal. Like we always assume innocent in a criminal court of law. You assume innocent. You assume equals. That's the null hypothesis. Always equals. Well, then what's the alternative going to be? Well, it's going to be the claim. P less than 0.51. And I'm going to write claim right there because that is the claim. So the claim on this problem is the H1 because they said that was the claim. So again, the null hypothesis is always equals, and then the alternative is greater than, less than, or not equals, right? So I said back here, it's greater than, less than, or not equals. How do you know which one? Well, they specifically said less, so it's less. All right, now they're giving me a p-value right there. Here's my p-value. P-value of 0.2429. What is that? That's move the decimal 2 places to change it to a percentage. You don't have to, but that's a 24%. That's the, well, you don't need to change it to a decimal. I probably shouldn't even mention that. Just keep it as it is. It's fine. What does p-value stand for? Probability. P stands for probability that the results are just luck. It's the probability that the results are just luck. You see, because that's the trick. Anytime we do something in any kind of experiment, or like if doctors try a new treatment, for example, if you have a new treatment for cancer and you give it to 10 patients and they do better, you got to be careful about concluding too quickly. Hey, this new treatment for cancer, it's better. It's been proven better. Well, not necessarily. Maybe those 10 patients you happen to first try it on were just going to live longer anyway. They were just more healthy people than the average patients. So maybe, the new drug's really not any better. You just got a lucky group. Now, if you only grab 10 patients, maybe you could get a lucky group. What if you grabbed 1,000 patients and they all did better? Could that be luck? Well, it always could be luck, but probably not. The chance of luck starts getting really, really low the more and more you do something. So that's what we're doing in statistics here. We're trying to figure out what's the probability that the results are just luck whenever we do anything. So if the P is low, here's the saying that we use. If the P is low, we reject, the null must go. So if the P is low, the null must go away. So if the P is low, then the null, HO, must go away. So that's the statement you want to memorize or put on your full sheet of notes for the exam. If the P is low, the null must go away. Because that means there's a low chance of luck. So remember, p-value is the chance that it's just luck. Maybe those new patients were just lucky. Maybe not. How do we know? Well, we calculate with statistics and to figure out what the p-value is. So when they tell us the p-value here is 0.2429, is that low? Well, usually a low p is under 0.05 or 0.01. They'll tell you in the problem it's the significance level. So significance level. So they'll tell you what this, like how significant the results need to be. Like for a new cancer treatment, you would want to be really, really sure that the new treatment is better. So you would want very strong results, like the chance of luck to be super low so that we know it's not just luck. The new treatment is really better. It's really working. We didn't just get lucky patients. We've done 1,000 of them now, and they're all living 10 years longer on average. That would be significant results. So they tell you that's called the significance level. Do you see it in the problem? It's right up here. Significance level 0.05. That's usually what they go for. Sometimes they'll choose 0.01. They'll tell you. So anyway, is our p-value, is it less than 0.05? No. It's 24%. This would be 5%. It's not. So our p here, so we're putting question mark, we say our p, which is 0.2429, is not less than 0.05. It's not less than the significance level. So it's not, so the p is not low. So the HO does not go away. You tracking with me? The p is not low. So the null does not go away. We keep the null. We keep the null in this case. So we're going to keep the null. What's the null? This right here. This was the null. We're going to keep the null. Meaning we believe that p equals 0.51. It equals it. We don't agree with the claim. We're keeping the null. That's kind of like a court of law. What do they assume in a court of law? They assume innocent unless strong evidence proves guilty. Right? The only time you convict a criminal and say they're guilty is when you have strong evidence, right? Beyond a reasonable doubt, they always say. If evidence is weak, so this one, let me come over here again. I'm kind of messing this up. There's a lot of writing here. So we're rejecting the claim, and we're saying if there's strong, only if there's strong evidence are you going to go with the alternative hypothesis, like somebody is guilty. If you have weak evidence, if evidence is weak, you stay with innocent. Well, that's what we're doing here. In this problem, the p is not low. There's a 24% chance, that's like 24%. There's a 24% chance that these just could have been lucky results. We could have just got a lucky group of adults. Right? We asked adults if they want to erase their personal information. We could have just got a lucky group. That's too much chance of luck. We want some stronger evidence than that. So that's too much of a chance of luck. That's weak evidence. So we're going to keep the original assumption, the null hypothesis, keeping that. So what's our answer here? Fail to reject the null. Right, we're keeping the null. We're failing to reject it. We're not rejecting the null. We're keeping it. We're failing to reject it because the p-value is greater than a, or alpha is what that is. Alpha is right here. That's the significance level. The p-value, which is 0.2429, is greater than 0.05, isn't it? It's greater than 0.05. It didn't come out less. It's supposed to be less. If the p is low, if it's less, then the null must go away. But no, ours was greater. So that's our option there. And now what does that mean? Like what conclusion do we draw? Well, remember what we said over here. Weak evidence. Weak evidence. I'm sorry, I pointed to the wrong thing here. Weak evidence for this. We're keeping the null. Whenever you keep the null, the original assumption, it's because evidence is weak. Just like in a court of law, whenever you end up saying the defendant being tried, you let him go, it's because there's not strong evidence to convict him. You assume innocent. unless strong evidence persuades the jury otherwise beyond a reasonable doubt. So if evidence is weak evidence, you keep the original assumption of innocence. So we keep the p equals 0.5 conclusion. So there is sufficient evidence? No. There is not sufficient evidence to support the claim that the percentage of adults that would erase all information is less than 51%. Right? We can't conclude less than 0.51. We're staying with the null hypothesis. There we go. Okay, number 3. 0.05, that's our significance level. Original claim, here's the claim. Let me write it up here. Claim the mean, so that's like mu. So it's not a proportion, it's a mean. So we have those two different options, right? So for mean we use mu. For a proportion we use p, don't we? So the claim is the mean of a certain group that's equals 73. All right, let's write the null and the alternative. HO, H1. So which one, what is null? Always equals. So we just grab this, and that's the claim, because it's exactly what the claim says, huh? So then what's the H1 going to be? It's always the opposite, right? This is innocent or guilty, opposite. So what's the opposite of equals? Not equals. Remember that? Remember that the H1 is always, so HO is always equals, and H1 is always not equals, greater than, or less than. Well, how do you know it's not greater than or less than? Because they never said greater than or less than anywhere in this problem, did they? Whereas the last one they did. The last problem they said, they said less than 0.51 somewhere. I don't know where they said it. Oh, right there. Less than 0.51. So we have that. But this time they're not saying less than or greater than anywhere. So there we go. What's our p-value on this one? P-value right here. 0.0966. Okay, so we've got to figure out if that's low or not. The significance level is 0.01. Is that less than 0.01 or greater than 0.01? That's greater than 0.01, isn't it? Than the alpha significance level. So that p-value is not low. That means, so remember our saying, if the p is low, the null, HO, must go. But our p is not low, right? It's not low. Our p is greater. It's greater than 0.01. It's greater than the significance level. Our p is not low, so HO, get kind of scribbly there. Let me try that again. So HO does not go away. We keep HO. Are you understanding how this works? It's going to be the same kind of thing every time, small variations. So there's the key statement. If the p is low, the null must go. Okay, so here we are looking at number 3. I don't know if I paused earlier or what, but I'll start it from the beginning again. Assume a significance level of 0.01. The original claim, the mean pulse rate is 73. So we have the null. So let me write the claim up here first. The claim is that the mean is 73. For means, we always use mu. For proportions, we always use p. So they're saying that the mean is 73. So I wrote equals. All right, so what's the null hypothesis and the alternative hypothesis? The word null, by the way, that just means that little zero right there. You call that HO or null. That little zero is called a null. HO. Anyway, so this is always equals. So it's going to be mu equals 73, which is the claim. Right, that's exactly the claim. Well, then what's the alternative going to be? Remember, the alternative is always one of these three, isn't it? It's always either not equals, greater, or less. Well, how do you know which one? In this problem, they never said greater than or less than anywhere, did they? So then it's just not equals. It's the opposite. It's the opposite of the claim. It's not equals. Because here's the claim, equals. So the opposite of that, not equals. All right. So now what's our p-value on this problem? Our p-value is right there, 0.0966. Okay, so how does that compare to our significance level? Is it greater than or less than? 0.09 is greater than 0.01, isn't it? So what does that mean then about our conclusion? Remember our main statement. If the p is low, the null, meaning HO, must go away. So if the p is low, the null must go. But our p is not low, is it? This p-value is not low. Our p-value is higher. It's greater. Right? Greater. Greater than 0.01. But our p is not low, so HO does not go away. Keep HO. We're going to keep the null. So our conclusion is keep the null, which always means weak evidence. Whenever you're keeping the null that's weak, the H1 requires strong evidence, just like a court of law, right? You assume from the beginning innocent, unless strong evidence comes forward that persuades the jury beyond a reasonable doubt, right? That's why it's got to be strong evidence. It's got to be beyond a reasonable doubt. Just no, it couldn't have been luck. We have 5 eyewitnesses saying he did it. It couldn't be luck. He must have done the crime, right? That's strong evidence. That's when you go with the alternative. You stay with the null is the original assumption, what you assume is true from the beginning before you've seen any evidence. And so if evidence is weak, you stay with the null. And evidence is weak. Why? Because the p is not low. What's p? The percent chance of luck. The chance of luck is not low. Not low. There's a 9% chance that these results just could have been luck. We want it less than a 1. It was not. We want less than a 1% chance of luck. That's our significance level. But we didn't get it. We had a 9% chance of luck. That's too weak of evidence. Evidence is weak. We stick with HO. So do we reject the null? No. We failed to reject the null because the p-value is greater than than alpha. Right? 0.01 right here. The p-value is greater. Now, what does that mean down here? Well, it's A. There is not sufficient evidence, right? There's weak, not sufficient evidence to warrant rejection of the claim. There's not enough evidence to reject the claim. Here's the claim. We're keeping the claim. We're not rejecting the claim. There's not sufficient evidence to warrant rejection of the claim. We're keeping the claim because evidence is weak. That's our conclusion. Okay, so question 4 is asking us about a type 1 error and a type 2 error. I want to call your attention at this point to the exam 3 notes. I spent a lot of time giving you really clean and compact summaries for these exams. I don't know if you've seen those. I post them on the Canvas course shell right before each exam, the exam notes. So here we go. Here's exam 3 notes. This is it. This is exam 3 notes, which is, you can get them right on the Canvas course shell. Download them. And here's part 5, which tells the type 1 and type 2 errors. This is what you're going to want. This is the notes you're going to want to have with you when you take exam number 3. So type 1 error, type 2 error. So let's go back to the question. So first off, the proportion of people who write with their left hand is equal to. So it's saying proportion equal to 0.35. That's what it's saying. Okay, the proportion of people who write with their left hand is equal to 0.35. So now, if that's the case, then if that's the claim, right, that's the claim, is let's write the null and alternative over here. Now, what is the null? Always equal. By the way, here's something else. Here's also from exam 3 notes. Number 3, where I'm explaining the hypothesis test setup. Just give it to you really clear and succinct. And it says you write the claim, P equals greater or less, or mu equal greater or less. And then you write the null, notice, which is always equal. And H1, if the claim was equals, then the H1 is not equals, and write claim next to it. If the claim was greater than or less than, then H1 is the same as the claim, write claim next to H1. And then it tells you if the P is low, then HO must go. Cross out HO, reject the null, strong evidence. If P is not low, greater than the significance level, then keep the null, cross out H1, fail to reject, weak evidence. So I'm giving you the pattern for every null hypothesis right there. So let's go back to the questions. Those exam 3 notes will really help you for exam 3. So again, notice HO is always equals, isn't it? Always equals. So it's going to be that. It's P equals 0.35. Well, then what's H1? Let's go back to the notes. If the claim was equals, our claim was equals, claim was equals, then H1 is not equals, and write claim next to HO. Not equals, and the claim is up here. That's what they were claiming. Right? Okay. So now we're ready to answer the question. What's a type 1 error? Or this one, type 1. What's a type 1 error? Type 1. Reject the null when it was true. So you reject the null. It was true. So it's an error. You're making a mistake. We're talking about a type 1, and then in a minute we'll talk about a type 2 error. These are mistakes we can make with hypothesis tests, just like mistakes they make in a court of law sometimes, convicting a person who's not guilty or vice versa. So a type 1 error is you reject the null when it really was true. You should have kept it. So what would that mean about real life and the proportion of people who write with their left hand? Well, that would mean that this is really true. The proportion of people who write with their left hand really does equal 0.35, but we rejected it. We rejected it. So do you see that's down here on D? We rejected the claim that the proportion of people is 0.35 when the proportion actually is 0.35. We rejected the claim. You think, what about this one? Reject the claim. But they said actually different from 0.35. No, it's not different. It actually is 0.35. That's D. Okay, so what's type 2 down here? Type 2. Let's go see it. Here's the notes, exam 3 notes. Type 2, fail to reject the null when it was false. Like you should have rejected the null, but you failed to. It was false. You should have rejected it, but you didn't. So that's if you failed to reject the null. So let's go back here. So type 2, fail to reject the null when it was false. So in that case then, let me put this back the way it was. Well, here, I can just do it down here. We have the we have the HO, P equals 0.35. The H1P not equal to 0.35. So the null is always that first one. So we fail to reject it. Notice we keep it. We keep it, but it was false. We shouldn't have kept it, but we're keeping it when, right, we fail to reject it, which means we keep it. We don't reject it, we keep it. We fail to reject means you keep it. When it was actually false, we should have rejected it, but it was false, and we kept it. So what would that mean? It means we believe that the proportion of people who write with their left hand is really 0.35 when it's actually false. So is it reject the claim? No, we didn't reject. Remember, this was the claim here. Right? The claim was the equals. So did we reject the claim? No, we kept the claim. Failed to reject the claim. It's one of those. Failed to reject the claim. It's this one. That the proportion of people who write with their left hand, when the proportion is actually different. Right? It's actually different from 0.35. We said it was equals, but it's false. Right? That's what a type 2 error is. Fail to reject when it's false. This is actually false. It's actually different from 0.35. That's answer C. D says is actually 0.35. No. It's different from 0.35. It was false. It's not right, but we kept it anyway. Let's try another one of these. Okay, so here we are again with the type 1, type 2 error. Let's see. So the percentage of high school students who graduate is less than 55%. Okay. So we have a null and alternative hypothesis. This says less than. Remember, the null up here is always equals. So then the less than must be down here. Is that making sense? The null up here, the null hypothesis is always equals. So that one is the equals. So the claim, right, less than 0.55 is down there, is the alternative hypothesis. So remember that the null is always the equals one. Okay, so now they're saying, what's a type 1 error? Remember type 1, let me go find it again. There it is. Reject the null when it was true. Type 1. Reject null when it was true. That's a type 1 error. So you said no to the null, but really it was true and this was false. But we rejected the null and we keep the alternative instead. So what does that mean? We reject the equals 0.55 when it's actually true. So we reject the null when that percentage is actually equal to 0.5. It really is equal, but we rejected it. That's the right answer. Now let's go down to type 2. Type 2, let's go back to type 2. Failed to reject the null when it was false. Failed to reject the null when it was false. Failed to reject the null when it was false. So again, we have the same null and alternative. P equals 0.55 and P less than 0.55, and this is our claim. This is what they originally claimed, less than 0.55. Okay, so with a type 2 error now, we fail to reject the null, so we keep the null, don't we? We keep it, so we reject the other one, but it's false. This thing is false, which means this one's true, but we keep the false one. Okay, so what would that mean in real life? We kept the null, so failed to reject the null. Yeah, that's right. We failed to reject it. We kept it. When that percentage is actually less than 0.5. Yeah, it's actually true that it's less than 0.55. That's the right answer. You could check this one, failed to reject, but it says it's actually equal to. No, it's actually less than. So it's A. Okay, study of 788 randomly selected medical malpractice lawsuits found that 504 were dropped. Point at one significance level to test the claim that most medical malpractice suits are dropped. Most. Okay, so let's write the claim. Test the claim that most. What does most mean? If I said most statistics students are going to get, in our class, are going to get an A or a B. Most. What does most mean? More than half, right? So the claim is the proportion is more than 0.5. That's half. More than half. That's most, isn't it? Most means more than half. So that's the claim, more than half. So let's write the alternative, the null and alternative hypothesis. All right, so how do we do this? Well, you know, the null is always equals. So this is P equals. So then what's the alternative? It must be greater than 0.5. And that's the claim. You want to write claim by one of those two. The claim is right here. That's the claim that most, more than 0.5. Claim goes right there. Okay. And remember how evidence works. There'll be weak evidence here, strong evidence there. If the evidence ends up being weak, we'll go with the null. If it's strong, we'll go with the alternative. It's always that way. All right, so which one of these on number 6 is right? It'd be this one. That matches ours. Okay, now how do we put this on our calculator? Well, I'm going to show you. Here we go. This is, again, the exam 3 notes, which are on the Canvas course shell for you to download and use during exam 3. So I'm on part 4 here, where we're talking about hypothesis tests using the TI-84. That's what we're doing. We've got to actually do one now. So, because they're asking for the test statistics. So how do we do it? Well, we're doing a P test right now because we're talking about P. So how do you do it? You go to the 1 proportion Z test under stat. So take your TI-84 calculator, hit the stat, I should say just stat. Hit the stat button and find 1 proportion, and then, I should say hit stat. Let me give you a little more information here. Hit stat and go over to tests. And then go down to find 1 proportion Z. That's because this is a 1 proportion, this is a Z test. And when you do that, it'll ask you for a PO, which that's the number from HO. You can remember now, we're going to get more and more fancy and advanced using our TI calculator and the rest of this course. So remember that whenever they give you something on the calculator screen with a 0, like PO, that means they want the thing next to HO. That's the signal. They're saying, I got a sub-0 here. Go to the other thing with a sub-0 and grab the number. That's the null amount. So what is it? What's next to HO? 0.5. So put in PO 0.5, and X is the number being asked for. What number being asked for? Well, let me go down to N. N is the total number. So 788, that's your N. That's the total number of randomly selected malpractice suits. 504 of them were dropped. That's your X. That's the number dropped. 504 were dropped out of 788. That's what we're talking about. That's the number being asked for, how many dropped, what percentage. We're trying to figure out what percentage were dropped, right? You know, that most were dropped or dismissed. So 504 were dropped out of 788 total. N is always the total. In everything we do in stats, n is the total. So put those into your calculator. And then it'll ask you for not equals, less than, or we're putting them all in the wrong order here, aren't I? It'll say not equals, less than, or greater than. And so we're doing greater. So choose greater, highlight greater. And then under calculate, whoops, I'm spelling it wrong, huh? Under calculate, hit enter. Hit enter under calculate. Boom. You'll get your numbers. You'll get 7.84 for your test statistic when you do that. Let me do this with you right now. Yeah, 7.84, rounded. That's rounded to three places, two decimal places. And now for the p-value, let me just tell you what I got. I got a p-value in my calculator. I got a p equals 2.326, blah, 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 blah. And at the end of it, I've got an e minus 15. Do you see that? Are you getting that on your calculator? Let me explain that. That could be confusing. What in the world is that? We've had that once, maybe one other time in the course. That e negative 15. Remember, that means take the decimal, move it back 15 places. Decimal left 15 places. That's what the minus 15 is. It's back once, and you're to the edge of the number. 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. What are all those going to be? Zeros. In other words, it's going to be, I didn't even do enough. It's going to be tons of zeros, like 14 zeros. So the p-value, in other words, is 0.0000000000000. I don't even know how many zeros. 2326. In other words, that's basically zero. That's just your calculator's weird way of saying p is basically zero. If you're going to round it to what? What do they want? 3 decimal places to 3 decimal places. It's zero. So understand that p-value is zero. It's not 2.32 because that e to the minus 15 means move that decimal 15 places left. So it's a whole bunch of zeros. 2326, rounded to 3 places. P is 0. All right, now we got to talk about what that means. Okay, so we got a p-value of 0. So let me bring this over here to a fresh screen. Again, write our null. P equals 0.5. Alternative, what was it? Greater than 0.5, and that was the claim. Greater than 0.5, that was the claim. And it always takes strong evidence to prove that. Weak evidence, you stay with the alternative, right? Because this is, yeah. So what did our p value? Our p came out to be 0. So if, and that's low. If the p is low, that's as low as it gets. If the p is low, the null must go away. So I'm going to cross out the null. My conclusion is going to be this. Strong evidence, because the p is so low, meaning the chance of luck. Remember, p is the percent chance of luck. The chance of luck is nothing. There's no way these results were luck. There's strong evidence. We believe the claim that the p, the percentage, is greater than 0.5, meaning that, let's get back to the question, that most medical malpractice suits are dropped, right? Out of 788, 504 were dropped. That's more than 0.5. That's strong evidence that really, for all medical malpractice suits that'll ever be done, that most of them must be dropped, because we looked at 788. That's a big sample. And 504 of those were dropped. So we believe that overall, most medical malpractice lawsuits are dropped. We believe the claim. There's strong evidence. The p is super low. The chance that we just got lucky 788 cases, that's That's just not possible. The p is too low. The percent chance of luck is super low. So the null must go. We get rid of their strong evidence. This person's guilty. There's a lot of strong evidence. And so what's our conclusion? Reject the null. Yeah, we're going to reject the null, but let's be careful here. Whoops, I'm getting lost here in the problem. We're going to reject the null. It's this one. Reject the null because the p-value is less than or equal to the significance level, not greater. And what does that mean here? This one. There is sufficient evidence, right? Strong evidence to support the claim. We believe the claim that most, more than 0.5 are dropped. There we go. All right, here we are on number 7. We're doing drug testing on number 7 here. Consider a drug testing company test for marijuana usage. 320 tested subjects. Results from 30 subjects are wrong, either false positive or false negative. So 30 subjects got wrong results. Use a 0.10 significance level to test the claim that less than 10% of the test results are wrong. Less than 10% of the test results are wrong. Okay. Let's try this. So what's the claim again? The claim, right there. Claim that less than 10%. So P less than 0.10. That's the claim. That's the percentage that are wrong. Less than 10% wrong. So less than 10% of the tests are wrong. That's the claim. So we got to write our HO and our H1. Remember, HO is always equals. So the H1 must, let's just P, must be less than. That's the claim. That matches the claim. Remember how evidence goes? It's weak evidence to keep the HO. You need strong evidence to go to the H1 always. So here's our setup. And now let's go on. So put this into your calculator. You've got to, again, here's what you do on your calculator. You go to go to stats, go over to tests, choose 1 proportion z test, put in P0, X, and N. So 1 proportion z test. And it'll ask you for, what's it going to ask you for? PO, X, and N. Move them over here. PO, X, and N. What's your PO? That's right here, right? That's the PO. The PO always comes from right there because it's the HO. What's the X? Well, how about what's the N? N is always the total. What's the total? 320 subjects. So then what's the X? 30 that got wrong results. So put that in. Now, and we're choosing a less than. So choose the less than option. Hit calculate. Hit enter. And I got a test statistic on this one. That's Z. Test statistic is Z. I got a test statistic negative 0.37, rounded to 2 places. I got a p-value. That's 0.355. All right, so what does that mean about a conclusion to this matter? Okay, so here, let me go to, let's say what the conclusion is. So what's our p-value in this one? This one. So remember how it works. If the p is low, then the HO must go away, that is. Is the p low? No. This is not a low p. What was my significance of 0.1? This is greater than 0.10. So if the p is not low, so our p is not low, HO does not go away. Instead, we keep HO. So we're going to keep HO because evidence is weak. That's just too high of a chance of luck. There's a 35% chance these results are just from luck. That's too weak of evidence. So we're keeping the original assumption, the HO, that P equals 0.10. That answer's right here. Failed to reject the null. Right? We're keeping the null. We're not rejecting it. There is not sufficient evidence, right? There's weak evidence to support the claim that less than 10% are wrong. No, we don't think less than 10% are wrong. But there's this study does not provide strong evidence that less than 10% of the test results are wrong. We believe they're getting 10% wrong, or maybe even more. Okay, so here we are in number 8. And this one, genetic experiment involving peas yielded 426 green peas, 120 yellow. Use a 0.01 significance level to test the claim. There's the claim. Let's write the claim. Claim is 27% of offspring peas. I moved to a new screen. All right, a little more room here. So 426 green peas, 120 yellow, 0.01 significance level. Test the claim. So here's the claim that 27% of the offspring will be yellow. So the proportion that's yellow will be 0.27. That's the claim. So we got to write, you know what we do next, right? We write the null and the alternative. The null, remember, is always equals, so that's P equals, right? Always equal for the null. So then the alternative, what's the alternative? If the null is equals and this is not equals, because it doesn't say greater or less anywhere. It doesn't say greater or less anywhere. It just says test the claim that 27% of this will be yellow. So that means equals yellow. That the proportion equals 0.27. 27% will be yellow. Right? It's not saying more than 27% are yellow or less than 27% will be yellow. That'd be greater than or less than. It's saying 20% will be yellow. So the proportion will be 0.27. And the alternative hypothesis is always the opposite, not equal. So the claim is right here. The claim can be either side, right? It can be HO or H1. The claim is HO this time, right? This matches this. So that's the claim, and you know that that's always weak evidence, and this is always strong evidence, like a court of law. What you assume, the HO, the starting thing is assume innocent, but that's if there's no evidence. If there's strong evidence, then we go with the alternative, which is guilt. All right, so we got to put this into our calculator, and so we'll do that. Put this into your calculation. One proportion Z test, and when we do, it asks us for P0, which is always the thing that's by the null, right? That goes with the HO, so that's 0.27. They ask us for the X and the N. The N is always the total. What's the total number? Well, that's actually going to be 426 green and 120 yellow. So you got to add those up. 546 total P's. 546 total P's. Got to be careful there to not accidentally put down 426. That was just green, and 120 was yellow. So the total number of P's is 546. And what are we talking about? Yellow or green? Well, we're testing that 27% are yellow. So the yellow number goes here, 120 are yellow. So put that into your calculator, and of course choose the not equals and hit calculate. And let's see what we get. I'm doing it as we speak. The not equals and calculate. So we get the test statistic here for for this question. That's negative 2.64, rounded to 2 decimal places. The p-value, that's 0.0082. All right, so what does that mean? What's the significance level? 0.01. That p-value is lower than 0.01, right? 0082 is lower than 0100 if you want to give them the same number of decimal places just so you can compare them more easily, right? So that's lower. So if the p is low, so I should have said if there. you know how it goes. If the p is low, the HO must go away, right? If the p is low, the null must go. So the null must go away. Cross that off. Keep the H1, which is not the claim, and which is strong evidence. There's strong evidence because the p is low, meaning there's a low percentage chance of luck. Remember what p-value means? Probability that these results were just luck. So these p's, this 426 green and 120 yellow and all that stuff, and what they came out with, that's not just luck. There's a very low chance of luck, only a 0.0082 chance of luck. So that's strong evidence that the p is really not equal to 0.27. So I forgot to, here was our answer for the first part, C. And then let's go to the other conclusion. Okay, so the p is low, the null must go away. So we conclude that there's strong evidence, right? Strong evidence to reject the null, and we believe p is not equal to 0.27. We reject the null. Let's go find that. So reject the null because the p-value is less than or equal significance. Yep. And what's the final conclusion? Down here, sufficient evidence to warrant rejection of the claim. Right? There's strong evidence, sufficient evidence to reject the null, which is rejecting the claim. See, the claim was up here with the null. We reject that when we reject the null. We reject that p equals 0.27. We believe it does not equal 0.27. So there we go. Okay, so number 9, a data set includes data from student evaluations, of course, the summary statistics, blah, 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 blah. Use a 0.010 significance level to test the claim. There's the claim. That's always the first thing we need. Claim that the population of student course evaluations has a mean. Now we're talking means, not proportions. See how they're all mu? So we're talking means, not proportion. That's what's different here now. Claim is that the mean equal to 3.50. All right, let's write the null and the alternative. The null is always equals. So then what must the alternative be? Not equal, because nowhere does it say greater than or less than. The claim is this one. The claim will be true with weak evidence, and the other one with strong, always, right? Weak always goes on the first one, null. Strong always goes in H1. The claim can be in either place. This time, again, like the last one, the claim is up here in the top. That's just what they claimed. All right, we're testing that claim. Now, we're going to go to our calculator on this one. Now, this one's a little different. It's a little different. Let's go look at our chart. So here again is the exam 3 notes. Exam 3 notes. We're talking about mean now. This is a hypothesis test using your calculator for the mean. No data given. In a minute, we'll have a data given couple problems, or at least one of them. But this one has no data given. What do you mean no data? Well, you'll see in a minute they'll list a bunch of data. We don't have data on this one. So what do? You choose t-test. So go to your calculator, hit stat, and then tests, and then go down to t-test. So it's saying right here, t-test. Now, when you get to t-test, you're going to choose stats Later we'll choose data when they give us data. We'll see that later. I think it's number 12. We'll see some data. Anyway, choose stats. And then it wants mu0. What do you think that's going to be? That's going to be the number from H0, right? Those are always that way. So what's my H0 here? I'll just put it back over here, I guess. So go to do the t-test. Choose stats, not data. So t-test stats. And then it'll ask for mu0. You know what that is. That's the number next to here. That's 3.5. That goes with the H0. And then it'll say, okay, what's the X bar? So that's going to be that always means the mean. Mean right here, X bar right there, 3.41. Then it'll ask for the S sub X. That's a standard deviation right there. 0.51, then it'll ask for N, which is always the total number of items in the sample. So this is a sample. They took a sample of a bunch of student evaluations. They took a bunch of student evaluations, 85 of them. The average score on the student evaluations was 3.41. The standard deviation, the average distance from the middle, was 0.51. So you put that information in, and you choose not equals. It's a not equals test. And then you calculate it, and here's what you get. The test statistic comes out to be minus 1.63 on your calculator. P-value is 0.107, rounded to 3 places. All right, so what does that mean then? What does this information mean? Is the P low? So remember how our statement goes. If the P is low, the null must go. If the P is low, the null must go. Well, the P is 0.107. Here's the significance level. Is that less? No, that's greater than 0.10. 0.107 is greater than 0.10, not low. So the p-value is greater, right? 0.107 is greater than 0.10. It's bigger. So this is not low. So if P is not low, then HO does not go. We keep HO. So we're going to keep HO this time. So that means so what is our conclusion? It's let me write it over here. It's a weak conclusion, right? Weak. We agree with the claim that mu equals 3.50. Basically, there's not enough, and we fail to reject HO. So we keep HO, we fail to reject it. It's weak evidence. There's not strong evidence. There's weak evidence. Right? If it was strong, we would go with H1. The evidence is weak because what? This is the p-value, the percentage chance of luck, the probability of luck. There's more than a 10% chance that this results, this data they got from these course evaluations, there's more than a 10% chance it could just be lucky results. That's not strong evidence. So we fail to reject the null. Weak evidence. We believe the claim that the average is equal to 3.5. We reject that it's not equal to 3.5. We keep the original assumption that it's equal to 3.5. So that would be this one right here. And what are we going to put down here? This is going to be fail to reject, as you know. Fail to reject the null. There is not sufficient, right? It's weak evidence, not sufficient evidence, to conclude that the original claim that the mean of the population of student course evaluations is equal to 3.50 is not correct. In other words, It's kind of a double negative that's confusing. There is not enough evidence, not sufficient evidence, to conclude that the original claim is not correct. This original claim, we can't prove it's not correct, so we keep it, right? There's not enough evidence to prove it's not correct. The original claim is kept. Okay, number 10. In a test of the effectiveness of garlic for lowering cholesterol, blah, blah, blah. They gave people raw garlic. They measured, cholesterol levels were measured before and after treatment. The changes, their levels of LDL cholesterol have a mean of 0.3, standard that. Use the 0.05 limits to test the claim. Here comes the claim, the most important part. What's the claim? That with garlic treatment, the mean change cholesterol is greater than 0. Mean greater, right, greater than 0. That's what they're claiming. See, I grab the claim first. I always start with a claim. On that, test the claim that the mean is greater than 0. All right, time to write the HO and the H1. What's the HO always? Always equal. Okay, now what's the H1? Should I do not equals? No. I have right here greater. So I need to do that and write claim next to that because that is the claim, isn't it? So this time the claim is on H1. Last couple of problems has been up there on HO. And then let's write right next to it. This is always weak up here. This is always strong evidence. HO is always weak. It's the initial assumption, like assuming innocence. And the H1 is always strong evidence. Okay. So it's time to go to our calculator. We're going to do what we did last time on this one. And so we're going to say, oh, by the way, that's B, isn't it? Got B here. So let's go to do a t-test on our calculator. And we're going to choose stats, because again, we don't have data. You'll see that in just a minute. And then put in the information. The mu0, that's just 0, right? That comes from right here. Comes from whatever the H0 has. That sub-0 should key your mind to look at the H0 and grab the number that's right there. And then X bar, the mean, where did it say mean? Right there, mean 0.3. And next comes the standard deviation, says it right there, 17.4. That means they tested some people, and what's the N? I don't know, how many people did they test? Where does it say that? I don't see it right now. Hello, where is that? Oh, I see. 64 subjects. So right there's my, that's my N, 64 subjects. So they took 64 people, gave them this cholesterol to see, this garlic to see, gave them garlic to see if it'll lower their cholesterol. They're claiming that it'll make a difference. It's the difference, the average difference, right? If they took their cholesterol levels before and subtract the after, they're claiming that it'll go down. So the subtraction is greater than 0. Does that make sense? If my cholesterol level was 100 before, and it's, before it's 100 and after it's 80, and you subtract those, you'll get 20, which is a number greater than 0. So that means the garlic brought down my cholesterol. That's what they're saying up here. Where do they say that? Before and after treatment, the change before minus after. See how it's before minus after? In there has a mean. So that's what we're measuring. That's the mu. It's the change. And you want that to be greater than 0, which means the before was bigger, which means the cholesterol was lowered by the garlic. So they're claiming the garlic lowers the cholesterol. Well, they tested it on 64 subjects. This was the average difference, the X bar, like when they tested them all and they subtracted the before minus the after, they got that average. That's barely above 0. That's not very high. That's not, so the average difference was only 0.3. That's not very much, with a lot of standard deviation. All right, so I doubt this is going to hold water, but let's see. So we did all that. Hit the buttons on your, after the N, you've got to choose the kind we're doing, which is greater than test. And then hit calculate. And what you'll get is a test statistic that is 0.14 and a p-value that's 0.445. That is not a good p-value. And what was our test level? 0.05 significance. That is certainly greater than 0.05. So if the p is so we'll say p is not low. So HO does not go. We keep the null. So we're keeping the null. Here's our conclusion. We keep the null. We believe that the difference is really 0. The garlic is not really making a difference because there's not strong evidence. There's a 44% chance that this little difference could have just been luck. There was just some reason their cholesterol was a little lower afterwards by luck, not because the garlic was doing it. There's a 44% chance it's just luck. That's weak results. So very weak. So we do not agree with the claim. We stick with the original null hypothesis, which means there's no difference. The mu is 0. No difference. So what do we say here then? Fail to reject, right? We keep the null. We keep it. We fail to reject it. There is not sufficient. There's not sufficient evidence, right? There's weak evidence to conclude that the mean of the population changes is greater than, well, there's not sufficient evidence to conclude that the population change is greater than 0. There's not sufficient evidence to conclude that. We don't believe the garlic helped. Okay, so here we are in number 11. Now we finally have data. This is what I mean by data. See how they're giving us a bunch of numbers? So whenever you see that, the first thing you're going to do, well, actually, let's go ahead and, that is data. Sorry, I should leave that. But let's get into the problem. Let's do below our lead concentrations in medicines. Use a 0.0 significance level to test the claim. Here comes the claim, most important thing to us. What's the claim? The mean lead concentration is less than 17. The mean is less than 17. The mean lead concentration is less than 17. That's the claim. What's the null? What's the alternative hypothesis? So you know how this works, right? The null is always equals. So the alternative must be the claim. Less than 17. That's the claim. And then where's the evidence strong and weak? Always weak on the null. Strong evidence required for the H1. All right. So which one of those is right? It's D. There's our setup. And now we go to our calculator. So the difference on this one now is, let's go to the notes. So there's the notes. So here's the notes. This time, okay, so this time, here we go. So this time we're doing mean. So this is hypothesis test using TI-84, mean, and data given. We're coming down there, right, because they gave us data. So what do we do first? Enter the data into L1, choose stats, then edit. So the first thing you do here is you're going to go stat, hit the stat button on your calculator, and then on edit, you hit enter, and you put the data into L1. That data right there. Remember how you do that? You first have to clear whatever else you have in L1. Remember, you go to do that, you have to go up to the top. Go up to the top of L1 and hit clear and then enter, right, and then put in the data. So I should actually put this down here. So first you go up to the top. You go to the top of L1. You hit clear and enter, and then you put data in L1. So put that data in L1, and then let's go back to this. So now enter the data into L1, and then go to t-test and choose data. So now hit stat, go over to tests, hit stat, tests, and go choose t-test, and this time choose data. And then when you choose data, it'll ask you for mu0. So what's mu0 going to be? Well, that's always whatever's next to h0. That's 17. And it'll ask you list. That should already be L1. It's saying, where's the list of data? So it should be L1. If it's not L1, make it L1. You know how to do that. You hit second and then 1, and it'll make an L1 there. It should probably already be L1. Frequency, we're just going to always leave frequency at 1. It means how frequently should I use each of those data values? Just one time. We're never going to do anything different than that. We just mean one of these, and one of these, and one of these, and one of these, and one of these. Basically, if you had like 100 20s in a row, you could change, there's the frequency of 100. Anyway, don't worry about that. We'll always have frequency 1. And then we're choosing less than. So choose the less than option and calculate. And it'll calculate for you. And so when you do all that, the test statistic comes out to be minus 2.16. The p-value, 0.029. Now that p-value, how's it looking? That p-value is, how's it compared to the 0.05? That's less than 0.05. The p is low. The p is low. So HO, whoops, I'm getting scribbly here. The p is low. HO must go. So cross off HO, keep H1. That's our conclusion, is H1, which means we have strong evidence, we believe the claim, the average is less than 17. That's our conclusion. So we reject the null, right? HO must go. We reject the null. We cross out the null. There is sufficient, there's strong evidence, right? Strong evidence to conclude that the mean lead concentration for all such medicines is, what do we conclude? Less than 17. So there's strong evidence that the average amount of lead in the medicines is less than 17, which is a good thing. There it is. Okay, number 12. An online poll asked, do you believe in the Loch Ness Monster? 20,486 respondents. 64% said yes. All right, use a 0.05 significance level to test the claim. Here comes the claim, most important part for us. Claim that most people believe that the Loch Ness Monster exists. Most. What does most mean? Or it's a p. It's a proportion, isn't it? These are all p's over here. What does most mean? Greater than 0.5. Most. Right? That's what most means. Right? Most is more than half. Right? Isn't that what most means? More than half? So that's the claim. That more than half, that most believe in the Loch Ness Monster. Okay, we have the null and the alternative. What's the null? The null is always equals. So what's the alternative? Greater than 0.5. It is the claim. You know how evidence goes. It's always weak evidence here, strong evidence there. All right, so now let's go to our calculator. Do we have, what kind of, this is a p-test, right? So I'm going to go to our calculator and do 1 proportion z-test. 1 proportion z-test. Okay, and then the first thing it asks us is P0. That's always the number next to H0, 0.5. And then it asks us for X, and N's always the total. What's the total number of people? 20,486 respondents. Right? That's a lot of people that were asked. And 64% said yes, they believe in the Loch Ness Monster. I don't know if they're joking or what. Now, what do I put here for X? 64%? No, not percent. Not percent, but number. The number that actually believed out of the 20,486 who were asked. Well, how do you find the number that believed? It says 64% said yes, they believe in the Loch Ness Monster. So you got to take 0.64, right? Because it says 64%. Let me just go slow here. Of the 20,486. That's our X. That's the number that believe in the Loch Ness Monster. So that means 0.64 of always is multiply in math. So 0.64 times of means times in math. So if you do that in your calculator, so I'm going to go 0.64 times 20,486, I'm getting 13,111.04. So just round that, get rid of the 0.04. It must be 13,111 people in that sample. 13,111 people said they believe in the Loch Ness Monster out of 20,486 that were asked. So there's what you put into your calculator under the 1 proportion z, and of course we're choosing the greater than option, and hit calculate. And when you do, oh, here was our setup. I forgot to say this is D, our setup there. When you do, you'll get a test statistic that's 40.08, a p-value that is 0. They want 3 decimal. They might want you to go 0.000 or just 0. I don't know how picky Math Excel will be. All right, so now what does that mean? That is certainly a low p. P is low, so the null must go. So cross off the null hypothesis, keep this alternative, which means there's strong evidence to believe the claim that the proportion is greater than 0.5. More than half believe in the Loch Ness Monster. Can you believe that? More than half. Strong evidence. In this study, anyway, asking 20,000 people if they believe in the Loch Ness Monster, 64% said yes. That's a lot more than a half. So there's strong evidence for the claim, to support the claim that more than half believe in the Loch Ness Monster. So that's A here, isn't it? We reject the null, right? We rejected the null. There is sufficient evidence to support the claim that most people believe in the Loch Ness Monster. That seems crazy. Is that really true? No. Here's what's going on. Look what it says right here. How is the conclusion affected by the fact that the internet users who saw the question could decide whether to respond? Remember how we studied this way back in Chapter 1, where we said if you give a question where most of the people don't answer it, like on the radio or on an internet website, you say, do you believe in the Loch Ness Monster? Most people aren't even going to answer. They don't believe in the Loch Ness Monster, and they don't care, and they're not going to bother to answer. But 20,000 people did respond. Yeah, those are the diehards. Those are the ones that really, really care about this Loch Ness Monster thing. They're really into it. You see, when you give a question, as opposed to like if you go out and you survey people one-on-one on the street or call them on the phone, you're more likely to get an answer from each person. And so you'll find out the truth of what people really think. But if you do something like on an internet or a call-in show, you're only going to get the extreme views. Remember that? You're not going to get what the average person really thinks. You're just going to get the extreme people's view, because only an extreme person is going to bother to call in or answer an internet prompt about whether they believe in the Loch Ness Monster. So this is not what the average person thinks. These are extreme views. That's what they're getting at here when they say B, since the sample is a voluntary response sample, voluntary, they could choose whether they respond or not. The conclusion might not be valid, right? That's not a valid conclusion. So there we go.